Recording in progress.
Right. Good evening.
Good evening, teacher.
Good evening, all of you. Hari, can you turn on the videos, please? Yes, all of you. Hari. Yes, all of you, hurry up. I'm waiting for you to turn on the video. So, yes, all of you. So I told you that I'm going to start the 6th unit today since we have finished the first, second, and third units. Right? We have finished the first, second, and third units. Today I will start the 6th unit, and also along with that I will start the 4th unit parallelly. At 6th unit is a biology lesson, 4th unit is a physics lesson, right? So we'll do both of them as we did the second and third units together, right? For about 1 hour. I will discuss the 4th unit first. I haven't shared any tute for the 4th unit. We will write because there are very actually it is not a lengthy unit, right? There are 3 important laws to learn, right? And we have to discuss about the practical applications next day. Okay, Hari. Yes, all of you who is V 2027, please rename yourself and turn on the video. Mansandi, Manusha, Pavani, Sasen, Akitya, turn on your videos. So you can take a set of papers and say this is unit 4. Unit 4. Newton's laws of motion. Newton. So you all have heard about Sir Isaac Newton, right? So what mentioned as Newton's laws of motion. Newton's laws of motion. Right? Before we move on to these laws, I have to give you the background knowledge related to the terms force and also what is meant by an unbalanced force, right? We will learn these first. Yes. The Ikmaning videos on if you have any problem, ask your parent to send me a message in through WhatsApp if you have any problem to turn on the video. Hari. Before we move on to the 3 laws of motion, I will let you know these facts. Right? There are certain things. Now, Imagine there is an object. Our fifth unit is based on friction, right? There also we have to discuss about this. Some of these things will be included in that lesson also, because these lessons are connected. Now there is a box resting on the ground, we'll say, right? Then you know how to indicate a force. In grade 9 you have learned that the magnitude of the force is indicated by the length of the straight line. Then the arrowhead indicates the direction of the force applied, and this is what we call as the point of application of the force, right? Hitana, this is a very heavy box on the ground. So you are going to apply a force on it, Venuka. Harida. So though you applied a force, the box does not move. The box නැත්තම් box එකක් ලොකු box එකක් හිතා ගන්නවා අමාරු නම් think of a cupboard. And you are trying to push the cupboard, but it does not move though you have applied a force. Why? What is the reason? Yes. I have applied a force, but it does not move. Why? What's your idea? Haven't you ever thought, why can't I move a cupboard or a vehicle alone? Yes.
Because the
Can.
force is not
Yes.
enough. Because the force we applied to that box is not enough.
Yes, Manushika. Manushika the that Manushika?
Yes, ma'am.
I think she mentioned the force that is applied is not adequate. Why? Why isn't it adequate? Because when this is in contact with the ground, there is an opposing force acting against the motion. When we are pushing it this way, an opposing force is applied by the ground. In the fifth unit, we learned this opposing force as the friction, right? In order to move this one, what should happen? We have to apply a force greater than this opposing force. In order to move this one, we have to apply a greater force. I will mention about these in friction. So here I will say that this is the applied force. This is the force applied by me. Applied force, right? Then here this is the opposing force. This is the opposing force. So what happens? The box does not move since the box does not move. Why? Since the applied force, the force applied is equal to the opposing force. Force applied is equal. Force applied is equal to the opposing force. Right? So that means since these two forces are equal, there is no any unbalanced force acting on this. Unbalanced nahi. The forces are balanced on this. We'll take another example. Now you have kept your laptop or the mobile phone or the computer on the table, right? So it is also something like this. So there is no any unbalanced force acting on it. Therefore, it is still. Why? The weight of the object is acting downwards and there is a perpendicular reaction acting upwards. Right? So this is at rest. There is no any unbalanced force acting on this. No any unbalanced force acting on this. And we'll say there is no any unbalanced force. No any unbalanced force acting on the object. Acting on the object. Take these concepts into your mind. Then especially in grade 10 and 11, you can't study by heart this part and expect the same part to be written on the question paper. අපි මොකක් හරි වාක්‍යයක් කටපාඩම් කරනවා ඒක හැමම ගිහිල්ලා ලියන්න questions එන්නේ නැහැ. Right? You have to understand the theory and you will have to apply that theory. Right? Therefore, take those concepts into your mind directly. හරිද? Acting on the object. That is the first fact that you learned here. When there is a force applied on an object, when there is no any unbalanced force acting on the object, therefore it does not move. It doesn't move. Hari, liya ganna number 1. Yes, Pavani, Anusha, Ernestine, and Sasen. Okay, Ernestine, noted. So the first conclusion is that when there is no any unbalanced forces acting on an object, that object is at rest, right? Does not move. Hari. So can add some more thing here. Moved, right? Here it should be object, right? Acting on the object. Still object. Still means not moving. It remains stationary. When there is no any unbalanced force, it remains the same. Then we'll move on to the next point. The next one. Now think of an object which is moving. You asked another 2 or 3 friends to come and join with you to push the cupboard. Right? When you all join together, you were able to move the cupboard. What does it mean? An object starts to move when there is an unbalanced force acting on it. Now, the overall forces, the collection or the sum of all the forces is greater than the opposing force. Therefore, you are able to move the cupboard, isn't it? And now, what does it mean? An object starts to move when there is an unbalanced force acting on it, right? An object starts to move when there is an unbalanced force acting on it. An object starts to move when there is an unbalanced force acting on it. Right, unbalanced force acting on it. So what is an unbalanced force? We can give certain examples. Now think of the same object. We'll say the force applied is 10 Newton and the opposing force is only 4 Newtons. So there is an unbalanced force towards this direction. Therefore, it will move towards that direction. We'll take another object. So here, this one, the ball. This is in contact with the ground. One of you applies a force of 6 Newton this way and your friend applies a force of 3 Newton to the other direction, opposite direction. So, there is an unbalanced force acting on both of these objects. Therefore, then it will move, right? An unbalanced force is acting there. Hari. එකත් note down කරගන්නකො. ඊට පස්සේ we will mention about 2 other instances of a moving object. මම මෙතනම ලිව්වොත් ඔයගොල්ලෝ පටලවා ගනි. I will write the next 2 on a new page. Right? Write this for the second point. Then I have to mention 2 other instances for a moving object, right? ඉවරයි නේද? Right. Next one. Number 3. අපි මෙහෙම දාමු. Moving object. We can talk about 2 instances. The third point that we are going to learn. So, the object was moving towards this direction. Direction of motion. Direction of motion is this way. In the fourth one, also, the direction of motion is the same direction, say. Hari. So, in this object, let's say an unbalanced force is acting to the same direction of motion. Right? An unbalanced force is acting towards the same direction of motion. A vehicle was moving on a highway or an expressway, and the driver applies a force on the accelerator. That means the unbalanced force is applied to the same direction of motion. This is the direction of the unbalanced force. Then what happens? මොකද වෙන්නේ? මෙයා ගිය පැත්තටම there is an unbalanced force. Then what happens? Yes, the object or this trolley මොකද වෙන්නේ? Accelerates or speeds up. It accelerates or speeds up. Now, what is the conclusion? If the unbalanced force is applied to the same direction of motion, the object accelerates or speeds up. Right? And we can say the object, since acceleration is a vector quantity, we will say the object speeds up. එයාගේ speed එක වැඩි වෙනවා. Speeds up. Right? Because in order to talk about an acceleration, we have to talk about a linear pathway. Hari. In this instance, this is the direction of motion. An unbalanced force is applied from the opposite direction. Unbalanced force is applied towards this direction. Then what happens? Yes.
The object slows down.
Yes, exactly. The object slows down. The object slows down. It is something like applying brakes when the vehicle was moving. The object slows down. Now, the conclusion is if the unbalanced force is applied to the same direction of motion, the object speeds up. If the unbalanced force is applied to the opposite direction of motion, the object slows down. Hari, you can write down. And in grade 7 also you have learned that force is a vector quantity. Force is a vector quantity. It has both magnitude and a direction. It has both magnitude and a direction. What is the unit of measuring force? Yes. කියන්නකෝ කෑ ගහලා. Unit of measuring force? Yes, that is Newton. Newton. Capital N. Done. Then ඔන්න අපිට යන්න පුළුවන් for the first law of Newton. Right, I will them in your textbook actually they have discussed about the practical applications of these Newton's laws of motion at the beginning, but I will explain the first law and the second law, and after that I will move on to these examples, right? Then only you will understand those. If you have any problem you have to ask, right? මේවා හරි වැදගත් because in the questions you are asked about the practical applications of these. Hari. Then we'll move on to the, I will move on to the next page, right? Newton's first law of motion. ඔන්න ඕවා දැන් ඔයගොල්ලන්ට මතකයෙන් කියන්න පුළුවන් වෙන්න ඕනේ. If you asked what is which Newton's law is applied here, sometimes it will be adequate to say that it is Newton's first law of motion. අන්න ඒකයි you have to understand the theory කියන්නේ. හරිද දැන් මොකක් හරි සිද්ධියක් දීලා they give an incident and you have to say which law of Newton is applied here. So you should have understood the theory in order to give that answer. And you should be able to express the three laws of motion by using correct scientific terms. Hari. You also can put the topic Newton's first law of motion. First law of motion. We have already learned the theory behind. In the Newton's first law of motion, he says, if there is no any unbalanced force acting on an object, the objects at rest will remain at rest. Harine? If there is no any unbalanced force acting on the chair, it will remain at rest, right? And he had mentioned about the objects that are moving as well. If there is an object is moving, a car was traveling on an expressway. If there is no any unbalanced force acting on that moving object, it will continue to move in a uniform velocity. In a moving object, if an unbalanced force is applied to the direction of motion, it will speed up. If the unbalanced force is applied opposing the motion, it will slow down. If there is no any unbalanced force according to Newton, it will move in a uniform velocity, right? That is the Newton's first law of motion. Until an unbalanced force is applied, objects at rest will remain at rest. Objects which are moving will continue to move in a uniform velocity. Harida, we'll write down, Emilian. Until an unbalanced force is applied, objects at rest remain stationary. And yes, until an unbalanced force is applied, හරියටම ලියා ගන්න. And objects which are moving or objects in motion continue to move in uniform velocities, right? Objects in motion Objects in motion. Continue to move in uniform velocities. Continue to move in uniform velocities. That is Newton's first law of motion. හරි නේද? And this is Newton's first law of motion. හොඳට මතක තියාගන්න. Until an unbalanced force is applied, objects at rest remain වෙන්න ඕනේ. Remain objects කියලානේ මම දාලා තියෙන්නේ. Objects at rest remain stationary and objects in motion continue to move in uniform velocities. හරි නේද? That is Newton's first law. Now, applications I will discuss next time. Then we'll move on to Newton's second law of motion. Right? Newton's second law of motion. And here we have to do a calculation. Newton's second law of motion. අපන් සතියේ පැයක් ගත්තාම මේ lesson එක ඉවරයි. Right? Newton's second law of motion. දැන් the victory is not finishing the lessons quickly. ඉක්මනින් ඉවර කරගෙන යන එක නෙවෙයි දිනුම. Right? You have to get the idea, you have to understand them well, and you have to practice those by answering the questions. Hari, Newton's second law of motion. Then මෙහෙම හිතන්න. We'll take this type of an example. You are riding a bicycle, right? Bicycle එකක් පැදගෙන යන ගමන් ඉන්නේ. Then you saw that a dog is coming behind your bicycle. It is running behind your bicycle. So what do you do? බැහැලා බලන් ඉන්නවද? එහෙම කරන්නේ නැති කෙනෙක් ගැන අපි හිතමු. You have to escape from the place as soon as possible. So you apply more force and ride faster. Right? වේගෙන් පදින්න පටන් ගන්න. ඒ කියන්නේ you apply more force. Then what happens? If you are traveling in a straight pathway, the bicycle accelerates nේද? When you apply more force on the pedals, the bicycle accelerates. හරිද? එහෙනම් මොකක්ද එකකින් උනේ? The force, once you increase the force, the acceleration also increased. Right? So the force is directly proportional to the acceleration. Directly proportional means when one factor increases, the other factor also increases. Right? When you apply more force, the bicycle accelerated. The acceleration is increased. Therefore, force is directly proportional to the acceleration. Then once again, now the dog is not there. You are riding the bicycle peacefully, right? Then you see that your friend is walking. So you want to give him or her a lift. Then you ask him or her to get onto the bicycle. Then මොකද වෙන්නේ? What will happen to the acceleration? Now the friend is too heavy. Yes, you are applying the same force. Then what happens? වඩා force එකක් දෙන්න බෑ. පුළුවන් උපරිම force එක දීලා තියෙන්නේ. Then it is too heavy. Then what happens? to the acceleration?
The bicycles
It
decreases.
decelerates.
It
It
becomes less.
decelerates. That means the acceleration reduces. That means the mass increased. The mass increased. Mass of the unit increased. Once your friend gets onto the bicycle, the mass increased. As a result, the acceleration reduces. And acceleration increased with increasing force. Acceleration reduces with increasing mass. When the mass increases, acceleration reduces. And that is what mentioned in Newton's second law of motion. He mentioned that the, the acceleration of an object is directly proportional to the unbalanced force. Right? It is directly proportional. On I will give it in words. So he mentioned that the acceleration is directly proportional to the unbalanced force. Directly proportional. This is the proportionality mark. Right? Acceleration is directly proportional to the unbalanced force. When the force increases, acceleration also increases. If the force reduces, acceleration also reduces. එකක් වැඩි වෙනකොට අනිත් එක්කෙනත් වැඩි වෙනවා. එයා අඩු වෙනකොට අනිත් එක්කෙනත් අඩු වෙනවා. අන්න ඒකට අපි කියනවා direct proportionality. Right? Then in the next instance he says that the acceleration is inversely proportional to the mass. ඒක ලියනවා මෙහෙම 1/m කියලා. When the mass increases, acceleration reduces. Or when the mass reduces, the acceleration increases. Opposite relationship. Opposing. අපි ඒකට කියනවා inversely proportional කියලා. The acceleration is inversely proportional to its mass. හරිද? ඔන්න ඔය දෙක විතරයි දැනගන්න ඕනේ. ඊට පස්සේ we can make you are not supposed to derive the equation. Derive කරන්නත් අමාරුවක් නේ. හැබැයි මෙන්න මේ දෙක දැනගත්තට පස්සේ you can use the final equation to make the calculations. හැබැයි මම derive කරලා පෙන්නන්න. නැත්නම් ඔයගොල්ලෝ බලයිනේ කොහොමද එකපාරට මේක ආවේ කියලා. Right? So here we can මෙන්න මේ මන් තරු දාන ටික විතරයි ඔයාලා දැනගන්න ඕනේ. එතකොට මෙතනින් මම ලියනවා acceleration is proportional to F over m කියලා. Right? F over m. Right? Then I can give this as, I take this part to this side and I write it as A divided by F over m is equal to a constant. If we want to convert this proportionality mark into an equal mark, we have to put a constant. හරිද? වැඩි හිතන්න එපා. මේ පාර්ට් එක කවදාවත් අහලා නැහැ මේ ඉක්වේෂන් එක ඩිරයිව් කරන්න කියලා. හැබැයි මේ දෙක දැනගන්න ඕනේ. Acceleration is directly proportional to the unbalanced force and it is inversely proportional to the mass of the object. හරිද? About this constant I can say that it is the force that is required for a unit acceleration. Right? මම ඒක වෙන කලර් එකකින් ලියන්නම්. The force required to make a unit acceleration. Unit කියන්නේ 1 කියන එක. Unit acceleration of 1 ms minus 2 on an object with a unit mass. Is there an insect on the board? Object of mass 1 kilogram is 1 Newton. කියලා තමයි we can define this constant. එහෙනම් we say that this is මෙතන ලියනවා A divided by F over m is equal to 1. From this we derive the equation. ඔන්න මෙයා තමයි ඊළඟට අපිට ඕනේ වෙන්නේ. Number 1, 2 and this is the third one. This is the equation that we have to use. F equals ma. Force is equal to mass into acceleration. Right? So mass is taken in kilograms, simple kg. Acceleration is taken in ms minus 2. So the force is given in Newton. ඔන්න එක සරක් O level paper එකේ අහුවා how to express 1 Newton by means of kg ms minus 2. So by writing the equation you can easily get it. Mass is taken in kilograms. Acceleration is taken in ms minus 2. So 1 Newton is equal to 1 kg ms minus 2. හරිද? ඔන්න මේ equation එකට substitute කරලා you have to solve the sums. Right? Now we will write the law in words. I will write it here. The acceleration of an object is directly proportional to its acceleration. To acceleration of an object is directly proportional to the unbalanced force acting on it. The unbalanced force acting on it. Unbalanced force acting on it while it is inversely proportional to its mass. Inversely proportional to its mass. So here it talks about the acceleration, right? You can underline this. The acceleration of an object directly proportional to the unbalanced force, and it is inversely proportional to its mass. Harida, this is Newton's second law of motion. Matakada, remember the first law as well as the second law. Harida, done. Now we can do some calculations. Yes, Pude?
Should we write these signs as well?
Yes, take this down. Then ogolo me first point you know already. You should know this. This first point, acceleration is directly proportional to the unbalanced force and it is inversely proportional to the mass. Derive karana හැටි එක සැරයක් ලියා ගන්න කමක් නැහැ. And mention about the constant as well and say this is the equation that we have derived, F equals ma. Very important. Yes, Venuka, Sasen inna neda Tisas. Tihasna, Tihansa, Deshika, Pavani, Savindu, Tenupa. So we'll discuss about an activity. The podi vela karagena api kanan kipekut hadala. Third law ekai, the practical applications I will discuss next week, right? First punchi vinadi pahaka break ekak dila, we'll move on to the 6th unit. Now, once we finish actually the 4th and 5th lessons, we can do lot of past term test paper questions, and even we can move on to some of the O-level paper questions as well in the paper class, right? එනිසා ඔගොල්ලෝ හොඳට මේවා familiar වෙලා join වෙන්න. ඉවරද? Have you all finished writing? Shall I move on to the next page to mention about an activity that we can do in the laboratory? Hari. And I'm moving on. So we'll discuss about an activity to demonstrate Newton's second law of motion, right? So you can take a trolley in the laboratory, and you can fix an iron nail or something to one end of the trolley, right? And not to one end actually, if either one side should be taller than the other side, or on both ends you can fix this type of nails, iron nails. Harida, in the first instance, what you are going to do is you have to fix a rubber band to one nail, and you have to extend it up to the length of the trolley. මේ පැත්තට iron nail එකක් තිබුණේ නැතත් කමක් නෑ, අපිට ඕනේ we have to extend the rubber band to until you reach the end of the trolley, right? That we are applying the force by using the rubber band till it reaches one end of the trolley, to say that we are applying a constant force. Rubber band එක මෙයාගේ දිගට ඇදෙනකම් we apply a force on it, right? The acceleration of the trolley increases with the force. That is what we are going to show. Acceleration of the trolley increases with the force. So we'll mention the method. So you connect the rubber band, and this is the trolley. So we can say that we are pulling the rubber band until it is extended to the other end of the trolley. Pull the rubber band. Pull the rubber band until it is extended to the other end of the trolley. Right? Then you can see that the trolley moves. Then as the second step, you are going to repeat the same activity by fixing two rubber bands. Two rubber bands extended up to the length of the trolley. That means you are doubling the force. The force is doubled. Then you apply three rubber bands and extend them up to the length of the trolley and observe. That means in each instance you are increasing the force. Once you increase the force, you can see that the acceleration also increases. Repeat the same using two 3 rubber bands. So here we can see, yes, acceleration increases. Acceleration is directly proportional to the unbalanced force. When the unbalanced force increases, acceleration increases. That is the first step. Hari, ඊළඟට කියන්නම්, take this down. Then හිතුවද ඊළඟ විදිය? Yes. Then we need to show that the acceleration reduces with increasing mass. Right? Acceleration of the trolley decreases with increasing mass. Acceleration of the trolley decreases with increasing mass. So you can take two instances with the same trolley. So you apply a force till the end of it by using one rubber band, right? Extend it up to the length of the trolley. And in the next instance, this is instance 1. And in the next instance, what you can do is, you can keep a weight on the trolley. On the same trolley, you keep a weight, right? An additional weight is kept, right? Then you apply the force once again only till the end of the trolley. You extend the rubber band till the end of the trolley, right? Here, this is the trolley, and here trolley with the mass. Trolley with the mass. Now we need to apply the same force and show that the acceleration reduces with increasing mass. How to prove that we have applied the same force? We are extending the rubber band up to its length in both instances. එතකොට අපි දන්නවා අපි දුන්න එකම force එක කියලා. With the mass. Right? Extend the rubber band until the other end of the trolley. දැන් මොකද කියන්නේ එකෙන්? Same force is denoted there. So we can conclude that when we increase the mass, the acceleration reduces. Therefore, acceleration is inversely proportional to the mass. හරිද? ඔය බලන්න පැහැදිලි අය, just raise your hands, turn on the videos. පැහැදිලි නැත්නම් අත උස්සන්න එපා. If you want a further clarification, just let me know. When we increase the mass and applied the same force, we can see that the acceleration reduces, right? It means that acceleration is inversely proportional to the mass. අර යාළුවා බයික් එකට නැග්ගහම acceleration එක අඩු උනේ. අන්න ඒ වගේ. හරිද? තිහාන්ස හරිද පුතේ? සයුල්, මන්සන්දි, දේශිකා හරිද? හරි නැත්නම් අත උස්සන්න එපා. If you want a further clarification, let me know, right? Ranudi, Akitya, Savindu, I can't see you all. Manusha. හරිනේ. එන්නේ ඔක්කොම අත උස්සලා ඉන්නේ. හරි. දැන් පැහැදිලිද? We have discussed up to Newton's second law of motion. Now we will make some calculations based on this equation, right? F equals ma. Finish writing quickly. some calculations. Right. Question number 1.
Excuse me, teacher.
Yes.
Teacher, when finding the answers for the question, we need to substitute the answer by an equation, right?
Yes. Here you can write the equation and find the answer.
Okay, teacher, thank you.
It's finished. බලමුද? හරිද ඔමික? Savindu, where are you? Tenupa? Oh, කට්ටිය. Hari. So here in each equation, if this is given for an MCQ, you can do it without writing anything. F equals ma. You have to substitute for the equation F equals ma. So m into a is F. 2 into 4 is 8 Newton. Right? In the second one, mass is 8 kilograms, force is 16 Newton. So according to, if I put numbers 1, 2, here 3 and 4. For the second one, you can say F equals ma and you are asked to calculate the acceleration. A equals F over m, right? So the F is 16 Newton. You don't need to put the unit, but remember that you have to substitute in kilograms, m is minus 2 and Newton. Right, here it is 16 divided by the mass is 8. Therefore, acceleration is 2 ms minus 2. Hari neda? Then number 3, acceleration and force are given. You are supposed to find the mass. So F equals ma. So mass equals force divided by the acceleration. So the force is 4.5. Acceleration is given as 1.5 ms minus 2. Therefore, the mass becomes 3 kilograms. 3 kilograms. Hari ne? කොබලන් මේ තුනම හරි අය. හරියන්න ඕනේ නේ? Okay. Last one, fourth one. So you are supposed to find the force F equals ma. but the mass is given in grams. So you have to convert it into kilograms. You have to say that it is 0.2 kilograms. And the acceleration is given as 20. So 2 into 2, that is 4 Newton. Yes, අන්තිම එක වරදිනවා වරදින් තියෙන if you haven't converted this into kilograms. සිහියෙන් ඉන්න ඕනේ නේද? Because in the equation I gave you, you have to substitute the mass in kilograms. හරි නේද? Right. Then, what is the unbalanced force needed to move a bicycle with a mass of 96 kilograms along with the cyclist in an acceleration of 2 ms minus 2? So the mass is given as 96 kilograms, acceleration is 292 Newton. The force equals 192 Newton. Very easy. හරිනේ? Last one. තව එකක් දෙන්නම්, චුට්ටක් වෙනස් එකක් දෙන්නම්. Number 3. Kiyan balan. Yes, send me your answer to the chat. Nathan kiyan taggal unmute karala. The answer you got. Okay, Sayul says 2ms minus 2. Hari, Devmini says 2, Disini 2, Yanuka 2, Ranushi 2. හොඳයිනේ. ඒ කියන්නේ that's easy. මොකද්ද මේකෙන් කියන්නේ? Trolley. There is a trolley. A force of 5 Newton is applied on it. Right, 5 Newton force is applied on it, and you know always the friction is an opposing force. That is 1 Newton. Therefore, you know that the unbalanced force acting on the trolley is 5 Newton this way and 1 Newton to the opposite direction, right? Therefore, the unbalanced force is 4 Newtons. Then you have to substitute for the equation F equals ma. Another concept you know that force is 4 Newtons. Mass is given as 2 kilograms into A. Therefore, A equals 2 ms minus 2. Harine, the hands up those who got the answer. 2 ms minus 2. Hari, okay, well done. Right. එහෙනම් අදට මේ lesson එක මෙතනින් නවත්තමු. I will give you a 5-minute break. Then we'll move on to the 6th unit, right? Hari. පුංචි break එකක් අරන් එන්න. Don't stay at the same place. Just go and come back within 5 minutes, right?